In passage 3, which is a data passage, we're looking at sunlight and its average insolation, which is the amount of energy per square meter at different latitudes or places on the planet. There's also a picture showing the average number of hours of daylight at those same latitudes or same places on the planet. For 13, it said, according to Figure 2, on average, the longest day of the year at 50 degrees north latitude is approximately how many hours long? So you have to make sure you're looking at the right line here. So 50 degrees north, you'd be looking at the diamonds that are not filled in. And the longest day would be the furthest up on the y-axis, and the highest up that you go on the y-axis is this point right here in June, and that is about 16 hours of daylight. So 13 was C. Number 14 says, according to Figure 1, the average insolation is greater on January 15th than on June 15th for which of the following latitudes? So you're looking for a higher insolation in January than it is in June. So basically, for all these latitudes, for all these lines, you're looking at a spot where in June you're higher up on the y-axis. I'm sorry, in January you're higher up on the y-axis than you are in June. And the only one that's kind of backwards that shows that is at 0 degrees. In January it's somewhere around 425, and in June it's below 400. So number 14 was F. 15, given the average number of hours of daylight for 70 degrees north latitude on January 15th, locations at 70 degrees north latitude on January 15th most likely have the average insolation closest to what? So for number 15, you're going to have to look at both pictures here. So for January 15th at 70 degrees north, so 70 degrees north, that would be these squares that are not filled on January 15th. There are no hours of sunlight. If there's no hours of sunlight, you should have no insolation. There's no energy per square meter if there's no sunlight. So number 15 was A. For 16 says, based on Figure 1, it is most likely that the average insolation at 0 degrees latitude and the average insolation at 30 degrees latitude are most nearly equal on a given day between what dates? Okay, so you're looking for, on Figure 1, a place where the insolation for 0 and 30 degrees north are equal. So that's where they're going to intersect, where on the y-axis they are the same. So for those two lines, right here and right here, they cross right here, and that is somewhere between March and April. So in between March 15th and April 15th. So for number 16, that one was G. For 17, which of the following graphs best represents the average insolation for 0, 30, 60, and 90 degrees north latitudes on August 15th? So for Figure 1, what you're looking at are these 4 points I have circled right here. And what I did is I just labeled them right here just so I could keep them in order, because you just read across and look at what the average insolation is. So the most was at 30 degrees north, and then as you went up to 60 and 90, it kept going down, and as you went closer to the equator to 0, it was at 420. So basically looking for a graph where that is accurate. And those numbers that I wrote above are numbers that would match the y-axis here. So number 17 was D.